Well, thank you, Samuel. I'll try to be the person you just described. It's quite intimidating. Yeah, I did some. I was very fortunate to have a year as a visiting professor in Brussels at the Vrije Universiteit. And one of the conditions for that is you have to write some joint papers with one of their members of staff. And so I wrote some papers with Karen, who is an educationalist, um, and it's a way in for me, of course, because I've been a philosophy teacher since the early '90s, so I think about teaching and teaching issues and pedagogy every day anyway. So it feels like kind of safe territory where I have reliable intuitions. Anyway, let's get on with this. So um, the idea of taking a cultural approach to mathematics does come in for some resistance, and I don't get to teach philosophy of mathematics. I teach other stuff. One of the things I teach is Nietzsche. And one of the things you get from Nietzsche is the idea that, people's motivations are always complex and um, never as highly theoretical as they might like you to believe. So I'm kind of interested in why anybody would feel resistance to taking a cultural approach to mathematics. So that's what I want to talk about today. And this will be guesswork, of course, because I can't actually get hold of people and psychoanalyze them. But then neither could Nietzsche, you know. But if you sit in enough seminars for long enough, you see how people react to different kinds of stimuli and you can take plausible guesses. So anyway, let's have a think about mathematical culture. The first slide here, the title slide, is about tying a necktie, its various tie knots. And the rhetorical question is tying a necktie a mathematical practice? And there is an answer from ethnomathematics, which is yes. Why? Well, because it has repeatable elements. You tie a necktie. There's three things you can do. You go left, right, or center, and by repeating those elements, you get your necktie. Why do people in ethnomathematics go for this kind of thing? Well, because part of the ethnomathematics program was to find mathematics in more or less in any culture you look at. And to do that, what you do is you broaden the notion of mathematics so that it includes things like decorative arts that have a lot of symmetry, basket weaving, string games. There are these brilliant studies of like cat's cradle string figures in the South, in indigenous cultures in the South Seas, which are presented as mathematical cultures. So if they are, then so is tying a necktie. But nobody is trying to persuade you that tying a necktie is a mathematical practice. Why not? Well, because the point of trying to persuade you that things like basket weaving or string games are mathematical cultures is to raise the status of these cultures and these practices, because they are, marginalized globally and in danger of being steamrollered by colonization. Whereas men who wear neckties, on the whole, don't need to have their status raised, right? So nobody is trying to persuade you that their practice that involves repeating patterns is a mathematical practice. There'd be no point. It's not a culture that's marginal. It's not a culture that needs to be validated and valorized. But of course, in order to do that, so one of the things that's at stake here is there's a politics to all this, right? that you what you think of as a mathematical culture is can be influenced by very respectable motives that to help people resist co-colonization. I mean, you could say about these practices they're really rich. You could just say they're really rich practices. We have nothing like them in our own society. They should be, valorized and respected just for that, rather than saying they too are mathematics. But it's a sign of the kind of status of mathematics for us that we want to kind of help these cultures by giving them the title. But in order to do that, in order to say, yeah, things like basket weaving or decorative arts are mathematics, you need a very broad conception of mathematics. So I'm going to tell you an anecdote about that, which I think I may have included in the thing with Karen that was just mentioned. When Euler received the Königsberg bridges problem, he said, "Why are you sending this to me? I'm a mathematician." Right? This is just some kind of general logic puzzle. And by the way, here is a general solution. But it was mysterious for Euler. Why would you send this to him? He didn't think this was mathematics. In order to think that this and basket weaving and the tying of neckties count as mathematics, you have to have a very modern, very recent, very pure conception of mathematics as the science of patterns or the science of detachable relational insights or something like that. So this is just my kind of title page, just to kind of limbering up to sort of remark that the concept of mathematics itself is historically and culturally variable, and also absolutely dripping with value and normativity. Okay, so let's step on. So like I say, I don't know for sure where the resistance would come from, what people's deeper motives would be, but I can think of three reasons really why somebody would want to resist, why somebody might feel resistance. And the three, I think, are there's kind of metaphysical anxiety, there's worries about essentialism, and there's worries about relativism. And I think that these are three that I think worth exploring. So the plan, first of all, I'm going to talk a bit about how I became an expert on mathematical cultures, right? That's an alarmingly short bit. Then we'll talk about the metaphysics bit and think about essentialism. It's kind of, well, what is a culture? And think a bit about relativism. Okay, so how I became an expert, and this is worth telling, partly because it allows me to pay some debts, but also because it allows me to sort of make some points about how research gets done. So here on the right, you can see this tower of four different interest groups. At the top, you have the UK government. The UK government wants researchers to do socially and economically useful research, right? They put a lot of money into research, into pure research. It would be nice if some of it did some good for people other than the researchers and their immediate community. I don't think this is, I mean, you're supposed to say art for art's sake and this is Philistinism and so on. Actually, I don't think it's an impertinent question. I think, I think if we imagine we're in a room and in the corner of the room is kind of notional taxpayer, we ought to be able to say something to the notional taxpayer about, what our activities are doing for that person. So the UK government, representing the notional taxpayer, would like us to do useful research. Now, research in the UK is funded in various ways, including by national research councils. If you're the Engineering Research Council, you can answer this question fairly easily. For the Arts and Humanities Research Council, it's difficult, right? If you're funding research into the history of theatre or, medieval poetry or something, well, what good does that do anybody outside the immediate scholarly community? So they have a problem. The AHRC has a problem. How do they persuade people to do socially or economically useful research in this area? So they created themes. They created a science in culture theme, because science is useful, right? Or at least it's more useful than English literature. So if we create a funding stream which would encourage people in the arts and humanities to collaborate or do something with or at or for or to science or scientists, maybe something more useful will come out of it. Now, I've divided these two because the Research Council as a whole is run by career administrators, but the Science and Cultures theme was run by academics, right? So different values, different interests. And at the bottom, you have some researchers. This is actually the Association for the Philosophy of Mathematical Practice, gathered in Paris, Poincaré Institute, but it's just like us. So we'd like to be paid to do the sorts of research we want to do. The people running the Science and Cultures theme they're kind of caught between, because on the one hand, they're part of an academic culture which is inclined to resist the call for the government's pressure to do socially useful research. On the other hand, they are academics who understand the pressures on the AHRC. So anyway, I put together the Mathematical Cultures theme network proposal, sent it off to the Science and Cultures theme panel, and they bought it, and we got the money, and we ran the 3 meetings and did the book that was so generously described in introduction. And I just want to mention Benedict Löwe and Thomas Müller, just because the Mathematical Cultures grant proposal, it was originally meant for a European thing. It was originally a cost proposal, and there's a whole other story about that that Benedict led and Thomas and I worked on with him, and that failed. So they didn't mind if I just kind of repurposed it and sent it off to the HRC. So this thing that we're doing together and the 3 conferences in the book all happened, not just because of some kind of pure research interest, but because I have to apply for research funds. Part of my job, if I don't do that, I get in trouble with the management. Looking around, it's a rule that if you apply for some special scheme, your chances are better than if you apply in the full open scheme. So this looked really good and it paid off. So this is like how research gets shaped, So this is part of what we're studying when we look at the kind of culture and value and practices and stuff that shapes knowledge. So some people are, if you're emotionally wedded to the idea of science as a kind of pure rational pursuit, then you're already uncomfortable, right? Because which book gets published and which project goes ahead being subject to these sorts of contingencies is already kind of discomforting. Okay, so that's ooh, that's some of my story. Here is just a few of the bits of prehistory, some of the older publications. So you can see Raum, 1938, Arithmetic in Africa. So there was ethnomathematics going on from early on. As soon as you have ethnology, as soon as you have anthropology, people start wondering about. And in fact, what's his name? Spengler, right? The Decline of the West actually opens saying there is no such thing as number. There's Western number, there's Asian number, there's African number, there's Native American number. So now, I mean, Spengler probably isn't our maître à penser that we want to take as someone to follow, but the idea of there being cultural differences is right there at the beginning of the ugly and frankly racist beginnings of anthropology and ethnology. The idea that this applies to mathematics as well is right there. What else we got? So we got some history. There's Klein. So we got ethnology. We've got lots of education. So there's Bishop. I'm going to talk about Bishop later. Vital and Skovs-Moser. I mentioned that one, The End of Innocence, Critique of Ethnomathematics. That's really important paper because coming out of Brazil, you have this ethnomathematics movement, where they worry about the fact that some of the worst secondary school maths results are for children in indigenous populations living on or in the forest, living their lives in an indigenous language, but then having to learn maths in Portuguese. So the idea is maybe we could make mathematics instruction culturally appropriate. Maybe it would be less alienating and more successful that way. But Vital and Skovs-Moser were doing field work in South Africa in the 90s, and the short version of that paper is equal but different, culturally appropriate education. Are you sure you understand what you're saying? The word for this in Afrikaans is apartheid, right? It may sound nice in Portuguese, but say it in Dutch and you'll see what the real political implications are, right?
Brandon, may I just quickly, this is a quick question. Why do you call this prehistory? In what sense is this a prehistory, or prehistory to what?
Oh, because there isn't a discipline formed. I think if we're now getting organized, I mean, basically, when does a discipline form? Well, I guess if there's a journal for it, if there's an international association for it, if there are canonical, if there are seminars on it, I guess then. When exactly? I mean, I guess in education, by the time we get to the 90s, they've already got ethnomathematics and cultural approaches. So maybe, yeah, Skovs-Moser probably doesn't count as prehistory. Raum, I'm fairly confident does. Yeah. But yeah, I'm thinking about discipline formation. But yeah, it's a good question. The thing I would want to make a note of is that there's no philosophy, right? Philosophers are mostly absent. We've got educationalists, historians, ethnologists. White has a paper there in Philosophy of Science in 1947, but it's a one-off. He calls it an anthropological footnote. It's a kind of, I mean, makes philosophical claims, but it's really a kind of an anthropologist saying, "I'll just tell you how it is." Okay, and Wilder. So Wilder is more recent, but Wilder. My feeling about Wilder is that he really he knows what he's talking about because he was a mathematician, not because he was a cultural critic who happened to know about mathematics. Okay, so we're already up to half an hour in, and I haven't said anything yet, so maybe I'll try and pick up the pace. So my first thought was metaphysics. And the claim here is that at least in English-speaking mainstream philosophy, you're supposed to start from naturalism, right? So the classic statement of this is Wilfrid Sellars, who says, "Natural science is the measure of all things, of what is that it is and what is not that it is not," right? So we're supposed to start doing philosophy on the understanding that natural science tells us what there is in the world, and we have to understand how we know that and how those things are connected, and how we're supposed to live in the world as described, more or less. I mean, there are obviously, there's plenty of dissent, but I think that's where the center of gravity is. And of course, in practice, what this means is that it doesn't start from what natural science says. It starts from what philosophers think natural science says. But the crucial thing is that there's a kind of naturalism or physicalism that's pervasive. If you look at philosophy of mind, the whole problematic is how do you find space for minds in a world as described by natural science. Now, I could say a lot about this. I have written about it. Rather than do that, because looking at the time, I'll just show you a slide. If you want the longer version, you ask yourself what Collingwood would say about this. Right? Collingwood is one of my R.G. Collingwood is one of my kind of philosophical guidelights. But the kind of core of the argument is that, well, the practice of science requires a whole bunch of stuff, some of which natural science can't detect, right? So there must be propositions, right? Remember, a proposition is an immaterial thing. And if you think about a proposition is what you're trying to preserve in translation. So like, der Schnee ist weiß, snow is white, la neige est blanche, one proposition, right? But it gets worse. And natural science can't detect those. It can hear you speaking, but it can't identify propositions. It gets worse because science is made up of arguments, which are themselves made of propositions. But the relations between propositions are difficult for natural science to detect. But of course, we don't just want arguments, we want valid arguments, right? We want science is supposed to be made up of good arguments. So somehow we distinguish the good ones from the bad ones. Natural science is never going to develop a detector for validity. You also need to know who's who, right? In order to practice science, you need to be able to detect academic status. There isn't a natural science can't detect that. And money, right? You need money to do science. And again, that's something that natural science can't detect. Now, of course, there are answers, right? I mean, thoroughgoing naturalists and physicalists spend their time precisely working out these wrinkles. So all I want to do now here is just kind of try and dislodge the idea that naturalism, as described, up here, is just the obvious starting point. That if you can't do the reduction from whatever it is you're talking about to the sorts of things that natural science can detect, then somehow you're not doing something intellectually serious. I think philosophy's natural home is on the inside of practice, right? So for us, these things are real. Okay, so that's thought one. Do I have another slide on that? Yeah. In contrast, and this is another sort of leading light of mine, C. Wright Mills. Okay, I see nodding. Who talks about the cultural apparatus, and his line, this is his great quote: the first rule for understanding the human condition is that men live in second-hand worlds, right? So there's a much bigger quote where it's a kind of sociologized Kantianism, right? Where the categories that you use to understand yourself, all of your experience is conceptually laden and conceptually ordered. Otherwise, it wouldn't make any sense at all. If you see a pen, it's because the concept pen is available to you, and so on for everything. Well, where did you get those concepts? Well, all right, they weren't hardwired into your consciousness. They are cultural products, right? One way of thinking of this is just a little joke. What's the best time to influence a child's development? The answer is about 100 years before it's born, right? Because that's when the culture that child will grow up in is originally formed. So the possibility of doing philosophy of science at all depends on conceptual order that we inherit, that is real for us, that is that is the medium in which we have our lives, the one in which we swim. The point is, once you're into taking a cultural approach to anything, means moving away from the kind of naturalism that Sellers articulates, and living more in the kind of intellectual space that C. Wright Mills wrote up. So yeah. So here's the section summary: is that taking a cultural view seems to entail giving metaphysical priority to a level of reality, what we're calling the social, that contemporary Anglophone philosophy usually considers to be derivative or fictional, right? So there's exactly how this goes depends on what kind of naturalist you're talking to and how much you play up the primacy of the social, but that tension is going to be there in some form. There's a note that I put in that maybe belongs somewhere else from White that he took in his paper I mentioned earlier. It's quite interesting that when you give cultural accounts, maybe this belongs later in the stuff about relativism, that both the species and the individual drop out, that the whole thing operates at a kind of local social level. Maybe we'll return to that, because keeping the forward momentum. Thought 2, essentialism. What is a culture anyway? Now I know that Jose talked about this book. I thoroughly recommend it. Lots of good stuff. Um, and they're worried when they say cultures without culturalism. By culturalism, they mean kind of cultural essentialism, right? So the idea that if you are Japanese, then you're going to do things in a quintessentially Japanese way, and so will all of your compatriots, and that this will, your Japanese-ness will manifest itself in the same way as everybody else, and in a way that won't change over time and doesn't. And I mentioned just because one of the papers in here is by somebody talking about Japanese physics, and makes precisely this point that cultures are internally diverse. They're changed by their own products, right? So a culture will produce, will do its own work and will change itself. Interactions with others, they're dynamic, and also the actors are relatively self-aware, right? So if you're with if you're with a lot of, particularly if you're at an international conference and you find yourself in a kind of nationally mixed group, but there's a bunch of your own compatriots, and you suddenly find yourself doing something typically, in my case, British, right? You will notice, right? And you might do something with that, either ironize it or dial it down or, whatever, instrumentalize it somehow. But this is what they're worried about. They want to find ways of taking cultural approaches to science without falling into what they call culturalism. I got that. Yeah. Okay. And one of the papers in here is by Fox Keller, and she talks about. So she, as well as being a scholar of epistemic cultures, she's also a feminist scholar, and she has this talks about the feminist experience. And you want to avoid any kind of essentialism. So whenever you use any category, be it a gender category or a cultural category or a political grouping, whatever, you then start worrying about an essence calcifying. You worry about the intellectual disease of hardening of the categories. So she talks about, and feminists talk about, strategic essentialism, where you allow yourself to talk about a category as if it was an essence for long enough to achieve whatever it is that you want to achieve, but you just keep in mind that it's only, provisional and for that purpose. And I read this and I thought, well, yeah, historians know this. Historians will be laughing reading this, because for historians, the whole, what kind of historian you are is partly a matter of what size unit, right? So if I ask you, tell me what happened last Tuesday, there'll be some historians who say morning or afternoon, because they're quite different, and there'll be others who say, look, you have to consider the whole week, right? And these are strategic research decisions. So there are some people who naturally put things in lumps, others who tend to split things into smaller and smaller elements. And this is, so for historians, this is kind of just standard stuff. Historians might wonder why, why anthropologists would be so exercised about this. So lumping and splitting it's always provisional, and that it's a strategic decision that you took for whatever your intellectual purpose is. I want to talk a bit. I haven't talked about maths much, but so I'll talk about maths now. Um, so here's Slava Gerevich. One of the papers in the Green Book is about the Gelfand seminar at Moscow University. So Israel Gelfand ran this seminar, and it was famously creative, but also famously brutal. That people would be invited, speakers would be invited. If Gelfand felt that the speaker was making a bad job of presenting his own work, Gelfand would grab the chalk and take over. He was always late. Sometimes he was 5 minutes late. Sometimes he was an hour late. But everybody arrived on time. And then when he was very late, people would start to talk to each other, and other mathematics would start to happen. Anybody could go. Anybody could go. Anybody who was confident that they could cope with the level of brutality, right? So there were high school students who went, but there were professors who stayed away because there were there was a lack of the usual academic civilities. And I mention this to make a point about scale. Because one seminar is too small, right? To constitute a culture. And besides, many of the academics who went to the Gelfand, there were other seminars happening in the same building in Moscow that just proceeded like we're doing now, right? Where the speaker is accorded their proper courtesies and so on, right? And there would be the same people, same institutions, same people. So what you have to do is explain how the Gelfand seminar was possible by talking about features of Soviet mathematics in general. And Gerevich does this a bit. He talks about there wasn't very much geographical movement. People weren't flying around to conferences in Soviet mathematics. So you have a very tight local community. Also, I mean, it wasn't that long after the Luzhin affair, right? People knew that you had to be careful what you said and who you said it to. So one feature of Soviet intellectual life was it tended to be much more lively verbally than on paper. Years ago, I studied with somebody who studied Soviet philosophy, and he said, they wrote rubbish, but they talked brilliantly, and they wrote rubbish to fulfill the 5-year plan, but the serious work was all done in conversations. But that required networks of friendship and trust. Yeah. So the people who were invited, the people who were shouting at each other, the people who were being rude to each other, it wasn't some visiting speaker from, from some other country. These people all knew each other. And so your cultural unit has to be a bit bigger. And it's those kinds of features that you use to explain something like the possibility of the Gelfand seminar. It's also significant that Gelfand was big in what was called the Department of Heat Transfer Physics, which was the atomic weapons program. I think it was kind of Soviet joke to call it the heat transfer physics department. Anyway, so yeah, a seminar is too small. But it can give you something to talk about. So here's D'Ambrosio, and he is right. I think he says, look, any collection of people can be an ethnos. When he's describing and instituting the Brazilian tradition in ethnomathematics, he says, look, any people who share a mathematical practice are an ethnos. So it's practices first. You don't start with like where they are or what language they speak or what gender they are. It's the things they do that make them an ethnos for the purposes of ethnomathematics. And that's got to be right, but it's also, it doesn't answer any of the questions about, well, where are the boundaries and how stable does something have to be? So one of the conferences we had was in China, and it was fascinating because there was lots of money from the Chinese government, but the Chinese government wanted essentially wanted China to be a world player in every department, including things like ancient geometry. So the Greeks have an ancient geometrical tradition. China also has one, and the world needs to know about it, right? So the Chinese scholars would say, well, there's Chinese mathematical culture, and then there's Western mathematical culture. There were people there from India who sort of said at this point, hello, would you mind telling us where we are on this map? Well, our question was things like, does theoretical computer science constitute a mathematical culture in an anthropologically robust sense, right? So there's a whole kind of mismatch between who wanted what and who was asking which questions. Somebody who offers an answer is Mackenzie. Still, his paper in Chemler and Fox-Keller. So he offers 4 criteria, and this is in the context of his paper about financial modeling. This is his contribution to understanding the 2008 crash, right? And he says, well, to have different practices, you have to have practice. To have different cultures, you have to have practices with 4 different features. They have to have different ontologies, different processes of socialization, different mechanisms of interaction amongst the participants, and path-dependent patterns of change, right? So there have to be different histories that get the members of the cultures to where they are. And Mackenzie, in when he writes about, he doesn't say this explicitly, but he seems to require all 4. And that would be a very robust criterion for when one culture stops and another one starts. I wonder, do you need all of them? The last one I think must be redundant because, if you have 2 groups and they're working with different ontologies, they have different processes of socialization, and they have different mechanisms of interaction amongst the participants, well, they must have got that way by having different path-dependent conditions of change, patterns of change, right? Because, how else? So maybe I've misunderstood Mackenzie on this point, but point 4 seems to be redundant. Thinking about mathematics, do we want to insist that 2 mathematical cultures have to have different ontologies to be so sometimes you can say that's right, so let's think about the last thing I did, I was elbow deep in 17th century analysis, right? So that whole world of moving points and fluxions and all of those kinds of very intuitive sorts of ideas that get beaten out of analysis in the following couple of centuries. And then think about the world of Euclid, right? The world of Euclid has it has shapes in it. It has points where two lines cross, but the lines aren't made up of points, right? You only have points in Euclid where they get constructed. So there you can see, you have two different cultures, different ontologies. But then, I mean, I remember in one of the conferences, somebody again talking about Japanese applied mathematics, and said, look, at a certain stage, it was a feature of the papers that Japanese applied mathematicians were writing was that they were really interested in the calculations, but they didn't bother to write a discussion of what this all meant in engineering terms. They were just excited about the calculations. And that was obviously the product of a feature of, features of the Japanese mathematical intellectual life that rewarded and was interested in novel and impressive calculation and wasn't terribly interested in the other bits. So they're a distinct culture because they have different values, and that different values lead them to do different things. But their mathematical ontology doesn't seem to be different from applied mathematicians elsewhere in the world. So maybe Mackenzie's first point is not always. You could have different values and different practices without necessarily, I think, in mathematics having different ontologies. This is the kind of point I make in the hope that I will be flooded with examples and counterexamples in the time available. Okay, so Mackenzie offers that. Notice that Moscow math seminars have the same four Mackenzie elements, right? If you think of the Gelfand seminar in one room and a very well-behaved seminar in the next room, the ontologies, socialization, interaction, right? They're all the same. So, and even on, on Mackenzie's criteria, they would be just one. I want to talk briefly about. So this is Time Team. Time Team was great because it had it's an archaeology program, but it had people who dig holes, it had people who do geophysics, and it had historians, and a lot of their archaeology was medieval archaeology. So the historian had to be somebody who was sufficiently posh to have learned Latin at an early enough age to become the sort of historian who can read medieval records. Whereas the archaeologists, professors who dig holes, had very distinctive working class accents, and in at least one case made a point of dressing like a farmer, right? That's down right there. And the geophysicists looked like physicists; they didn't look like archaeologists. And it was really interesting because they would disagree. They would all have bits of partial evidence, and the geophysicists would say there's definitely something interesting there, and the historian would say, well, there's nothing in the records, and so on. Right? So you got to watch related but very distinct, socially, culturally, and epistemically distinct disciplines trying to work together. And thinking about our remarks, at the start about, well, here we are, some of us are historians, some of us are philosophers, some of us are educationalists and whatever, and logicians and whatever else, and we're trying to work together. Well, it was all happening on Time Team, and you could see that evidence that was compelling, historical evidence that was compelling for the historian, just didn't move the others. Not because they couldn't understand the argument, just because they weren't historians, and so it didn't weigh that heavily, right? maybe rather that well, it's the differences is where you find the borders. But leading on to the thoughts about mathematics, of course, one of the things people care about in mathematics, one of the things that people find valuable in it is that it crosses boundaries. It crosses. So here is, discussions of the Pythagoras theorem, one from ancient China, one from the Islamic world. When I made this slide, I thought I did it like this, and I thought maybe I should put the Chinese one on the left because it's older. And then I remembered what I was talking about and left them the way they are, right? Because of course time flows from left to right. So we have, an extra layer in mathematics precisely because it reaches across time and across continents. And okay, so the section summary, and I'm aware that I've been talking for an hour now, and that kind of is the limit, although we did kind of start 10 past, so I'll keep licking along. So the section summary is, well, taking cultural review can smell of ethnic essentialism or even apartheid to some people, and for others it's going to smell like, woke identity politics. Certainly some of the earlier ethnomathematics, and I mean, if what do you imagine arithmetic in Africa written in 1938 is like? Right. I mean, so, but moving on to the next section, mathematics as a transcultural, colorblind, shared knowledge is part of its appeal, right? So one of the things people find valuable in mathematics, and I'm going to talk about Bishop now, and Bishop is really interesting for this. Thinking about relativism. So here's Alan Bishop. He lays out these this little grid in various places, but one of them is the paper I've read most recently is this one, Western Mathematics, the Secret Weapon of Cultural Imperialism. So there's, the political orientation is right there already. Now he divides these values. He got 6 values he associates with mathematics. He divides them into ideology, sentiment, and sociology. I find that unhelpful because the values of a culture, the same value will show itself in the ideology, in the sentiment, and in the sociology. It's not like, people care about one thing in the way they talk, and then their feelings about something else. So I'm the bits in italics I'm inclined to just drop. When he talks about rationalism, well, mathematics, truth is determined by proof, and the point he makes is that relentlessly going for logic can be divisive, and in some cultures value social ease and respect for hierarchy more than they do logic, right? So he gives the example of a student who is raised in a particular religious tradition, but is also doing a medical degree. And so the professors in the medical degree tell him that, the earth is so many billion years old and that life evolved through more or less Darwinian. The religious elders tell him a completely different story about the origin of life and how old the world is. What do? You respect, because you care about hierarchy. Your world is ordered by social hierarchy, so you just respect both. And it's an exercise in what Max Weber called the inward plasticity. He think one of the problems that we have as thoroughly rationalized modern subjects is that we've lost the inward plasticity of ancient peoples, which meant that you could worship gods with completely different principles. You could worship the god of passionate, eros, and also the goddess of hearth and home at the same time, and it didn't matter, right? As long as you'd made offerings to both of them, it didn't matter that there was a contradiction. Whereas we now talk about everything and worry about consistency and coherence, and so we make our lives that much more difficult. There are people who still have inward plasticity, and in that way manage to just reconcile hierarchies, the top people in which say can think contradictory things. If what you care about is social ease rather than logical rigor, then mathematics will seem to be unhelpful and divisive. Bishop also, when he talks about rationalism and mathematics, is rationalism in the sense of Weber, and there's echoes of Skovsmoser talking about formatting the world. I'll skip over that. I'll just take it. I'll just take it that you've all read Weber and Skovsmoser, and if you haven't, we can come back to it. According to Bishop, mathematics prefers objects to processes, and has a tendency, and this is true, right? Has a tendency to make objects out of processes. So you start with mapping as a verb, and then you talk about mappings, and you study, a whole space of functions. So what starts out as an activity that the mathematician does becomes a structure that the mathematician then studies. According to Bishop, material objects are the paradigm. So things, mathematics thinks about everything as if it were stable, detachable. Whereas the world we live in is full of processes. And in particular, the social world is full of unstable, ephemeral processes. Prefers artifacts to nature, right? Is happier talking about squares and circles rather than the shapes that lakes and animals' bodies make. Talks about mathematics being associated with control, mathematics being associated with progress. The crucial point is that progress in science and mathematics means that structures of knowledge and authority are provisional, right? Whereas, the cultures he's thinking about, authority is taken to be eternal and unchanging. Mathematics is supposed to be open. In principle, anybody can learn it. Right? It's difficult, but it's not intrinsically esoteric. You don't need to belong to a particular social class. You don't need to be born into the priestly class. You don't need to be any particular gender. If you're a high school student in Moscow and you're good enough, you can go to the Gelfand seminar. In principle, it's also associated with mystery, right? There's the whole beginning, all the way back to Pythagoras. There's kind of number mysticism and the idea that there's kind of otherworldliness associated with mathematics. So here's a photograph. There's Paul Erdos bent over a problem with a 10-year-old Terry Tao. This illustrates both points. Because, of course, Erdos was a kind of otherworldly figure. He was a kind of wandering sadhu of mathematics. And if you're a 10-year-old genius, it helps if you're in a situation where somebody will arrange for you to be in conversation with Paul Erdos, right? doesn't happen to everybody. Now, a lot of this bishop stuff depends on a kind of problematic Western indigenous contrast that by now we ought to be doing better than. But he's right that mathematics is associated with Enlightenment, anti-aristocratic, anti-clerical, and cosmopolitan values. Right? So it really struck me when I read Bishop for the first time. I thought, this is the Enlightenment values being associated with mathematics here. And he's right. People who value mathematics very often value it for these sorts of reasons. And if you take a cultural approach, it can sound as if you're undermining these, that you're saying, well, mathematics is one kind of knowing, but there's also, got to give some respect to the tradition and the priesthood and so on. And just a last thought on, there is and this is something that Jose talks about. We don't need to worry too much about relativism in mathematics because the roots of mathematics are part of common human experience. So Brouwer talks about the bare two oneness of your experience is split into the past and the future. So there's a one-two-ness, right? Your experience is a whole, but it falls in naturally into two parts, and that's common to everybody. So that's him doing sort of updating the Kantian story of the origins of arithmetic. You don't necessarily have to believe that, but there's something right about the idea that we are all always already counting. Everybody counts, even like the Mundukuru, even cultures where the natural language doesn't have systematic counting terms. If a member of one of these cultures has 7 fish and you take one, they will notice, right? They know how many fish they've got. They know how many children they've got. Everybody counts. Almost everybody measures. So it's not that surprising that although mathematics differs from place to place, it's people can understand each other's mathematics more easily than they can understand each other's religions. So, ancient Egyptian religion is very difficult to understand, right? To try and imagine what they thought they were doing. Why was it essential? You think about the centuries and centuries of pharaohs who know that all of their predecessors' tombs get robbed. Why didn't they just choose not to be buried with mountains of treasure, right? But there was something about death and the afterlife and kinghood that made that just unthinkable. We understand, we can read their writings, we still don't really get that. But measurement, we absolutely get. We know what they were doing here. This is a soul being weighed against a feather, I think, but we understand weighing, even when it comes from that far back. So here are a few things I wrote that I just included in case anybody's interested. With the again, I'm grateful to Benedict and Thomas and their Chinese co-editors for publishing that one, and for Karen for being a very collegial co-author on those things. And that's it. That's what I have to say about all that.